that I created a game. It's called Rock, Scissors, Bacon. Now the trick is bacon always wins because bacon can top anything, right? Now the game doesn't last very long because everybody figures it out, but that's okay because everybody wins with bacon. So here's how it goes. That's my bacon joke. Are we good? Awesome. Okay. This talk is about how graph databases can save your bacon. So that's the theme. Now we are all connected more than you realize. You've probably heard the 6 degrees of separation. Is it really true that everybody on the planet can be connected by 6 relationships? It's kind of hard to believe, but the world that we're in is getting smaller every day. Now, it's a popular meme. I looked it up on Wikipedia, and there's a lot of detail on who it's from, and there's actually some psychological research that was done in the 1960s, I believe, about how mail travels and getting one person to send it to another person they don't even know by the fewest possibilities. And it's actually a popular meme. There's even a party game about it, about bacon. You know that. And that's Kevin Bacon. We know who that is. Now, I'm going to share with you a story, the story that inspired this talk. There's a place that I've made up, but the story is real. And the place is the BONZAI Bacon and Banana Cabana.com. And I'm going to introduce you to a designer. His name is Kevin, the CSS guy. And this is not him. Okay, mustache, whatever. So it's almost go live time. We've been on a project for 2 years. And here's Kevin. He's been added to the team in typical Fred Brooks Mythical Man Month style. They give him the task of fixing all the CSS that the devs have broken. Not my fault, mostly not. Let's have him fix the CSS. Now the problem is, Kevin doesn't know the code base. He's totally brand new to it. It's ASP.NET MVC. And he also doesn't know Visual Studio. So we've got tons of style sheets and lots of code, and they're like, hey, CSS guy that doesn't know ASP.NET, go fix this. And so you can imagine he's probably thinking, you know, how am I going to find all the style sheets, and where do I start? How do I know if I've broken anything, even if I do make fixes? And then I started thinking, hey, no sweat. We'll just run a bunch of regular expressions on the code base. That always works. And then I go to Kevin. I say, you know, hey, I can help you. I can help you. And I'd never met him before. And he's like, you know, hi, how you doing? My name's Kevin. And I'm like, yeah, I got this great idea. So I'm like, I can help you out. All you need is some regular expressions and a graph database. And he's like, okay, I just met you. We're not on that kind of relationship yet. So these are not new problems, right? Every day you have the developers, they go and make changes, then they don't have the full knowledge of the system. If you're on a large development team, you know, maybe one of 10 or 15 developers, you're like, you know, this little piece of the system. And you got the DBAs, they optimize the schema every other day, and they're adding tables, dropping columns, and you're like, what are you doing? And then the bugs might go undetected for a while. So, and when that happens, the fixes are really costly, not only in time and money, but in like credibility. You know, your team gets dinged every time a bug goes out. They're like, do you know what you're doing? But what if we could locate problems ahead of time? What if we could prevent the defects in the first place by taking an approach that I'm going to show you? Graph databases can make a big difference here, and the key is in modeling your process. Now, what's a graph database? Well, I thought we had databases figured out. You know, there's tables and rows and columns. I mean, it's CRUD, right? What else do you need? So, first question is, what's a graph? And a graph in mathematics is a set of nodes that are connected by edges or relationships. Just a note about the word node. I just think that's a really weird word. So just kind of take that for face value there. And this is an example of a graph. We've got 3 little circles and 3 little arrows pointing at each other. And it's not like the developers blaming each other. It's just the concept. So what's a graph database? Well, a graph database is a database that's designed to efficiently store and retrieve these nodes and edges. And this is an example of something that you can model in a graph database. Now, this is what I call a domain. This is the testing domain, and of course you've got requirements, you've got test suites and user stories, features, user personas. And all these things kind of relate to each other. Now, if you can imagine building this in a relational database, that's not a lot of fun. And here's another domain. There's the people in your process, the human element. There's a person, there's the teams, the groups, the organizations that play, and the roles that they're in, and audiences for your content. And then domains can have overlaps. So if you can imagine your development process, you're basically all the things that you forget that you need to track. Like if you're in a group and you've got a bug tracker, you've got maybe an ALM system if you're really lucky, sort of. And then you've got your email and SharePoint and all these other things. And so there's all these things that you want to track, but you're not really connecting them all together. So here we have the the process domain and the human domain. Now the process domain also includes the testing domain. So we got iterations, check-ins, releases, and tasks that are processed, but then we have the testing domain, which is user stories, test suites, etc. So what you begin to see emerge is this connectedness. And of course, you have the knowledge domain. The knowledge domain is all the skills and documentation and all that knowledge that seems to get lost every time somebody quits. Now here's another sample process. You can see it a little bit closer there. We have requirements, user stories, releases. All these things go together to make up the system that you're building. So that's what I'm approaching today. Now this is an even bigger graph. If you get really ambitious, you got all these relationships. Now imagine trying to build a relational database to model everything. A web domain. You've got a controller, you've got a CSS file. Now what's different about a graph database? Well, relationships in graph databases are first-class citizens. In a relational database, you've got foreign keys. You probably know what those are. And if you've got many relationships between two kinds of items, then you've got a table in the middle called a many-to-many table. And in a node-based graph database, you don't have that at all. One node can relate to the other, and it can be of any kind, have any kind of relationship, and you don't have to set up all these tables. Here's an example of the relationships. Now you see the effects relationship, settings, affect features, permissions, affect features. Notice that the relationship has a type to it. That's a feature of graph databases. Graph databases are easy to change. They don't have a schema requirement. If you've seen some of these NoSQL databases that are schemaless, this fits in that category. You can always add constraints and things to give it structure, but you're not required to. You can always add a property on an individual node if you want to document one particular aspect of one node. Even if you don't have that on every other node, you don't have that column running down the side with no data. And you don't have the recursive queries. If you've ever done a category query where, you know, like a navigation, you're on a home page or something, you got, hey, let's drill down. Well, you don't have to worry about that with a graph database. Okay, so great, graph database. So what? How does that help my team? Well, visual models convey lots of information. I mean, I breezed through several graphs already, and you probably said, oh, cool, it's a picture with colors and little shapes. I mean, I didn't build that in Visio. I built that with my graph database. Now, it lets you begin to think visually. So you're working with concepts instead of words. And I think that engages a different part of the brain. And it lets you see relationships between things. It also helps you to see what's missing. I can easily look at a model and a diagram and I can go, hey, wait a minute. See this up here? It's only connected to a couple things. Why isn't it connected to these other things? Right? So visual thinking is a big advantage. Now, here's a news flash. You are disconnected more than you think. Now, you're disconnected from your code, your team, and your process. So all these things work together, but they're in conversations, they're in stand-ups, they're not actually modeled. Now, if you don't believe me, the question is, can you answer questions just based on empirical data? Like how much test coverage you have? Well, you probably have some kind of measure of that. But can you measure by feature and by release or by check-in? If you make changes to a style sheet, what do I have to have my users test again? Or who's worked on a feature and how much code thrash is there on a particular feature? And where are the defects showing up? Well, these things cross boundaries, and that's what's really great about a graph database. So you're probably wondering, well, I've got spreadsheets, I've got Excel, what's the big deal? Well, just like relational databases, you're going to have a lot of data connecting these disparate things. Lots of tabs. You're going to have a tab for every type of data, a tab for every type of relationship. And if you've ever tried to figure out a VLOOKUP, I have to look up the reference every time. I'm sorry. And then if the spreadsheets live in SharePoint, good luck finding it again, just saying. Now, I'm going to show you Neo4j. That's the graph database we're talking about. It's open source. You can go to neo4j.com to get it. And it has this really cool query language. And it's a query language designed specifically for graphs. You know, you've got SQL, you know, structured query language for relational databases. Well, CYPHER, and notice there's Neo and CYPHER. If you have ever read the background on it, it's named after the matrix. And so this is SQL for graphs. Now, you've got your basic keywords, you know, the CRUD stuff. We've got create, match, and return, and then merge and set. That's kind of like update, if you've seen that. And then, of course, delete. No big deal. And here's an example of a create query. Now, there's several components to this. There's the keyword. There's an identifier that we're using just to keep it as a placeholder for later use in the query. Now, what you see here is a label, hero. Okay, what is that? Well, that is a way to designate that this particular node is of a certain class. And that's not class in the OO sense. But in this case, we've got a hero. Whoops, sorry. Okay, we got a hero named Iron Man. It looks very JSON if you've ever done those. And then we just return the value at the end. Okay, so pattern matching. Pattern matching is a really cool feature where you can do query by example. And all the properties that you give it a value to, it's saying implicitly where this, dot, that equals that, et cetera, et cetera. And then you also have where clauses just like you would in SQL. So if you want to just return your entire database, you can do that. I wouldn't advise it. I call this the Goldilocks query because it's like, whoa, that is just too big. Okay. Now, this one is an example of the pattern matching. So we've got a first name of John. And we're going to say basically just return 25. We don't know that they're the top 25 exactly. We're just saying, all right, don't give me the fire hose. And then relationships are directional. One node A relates to another node B. And then in addition, we have how many hops it takes. So you can specify in your pattern matching, hey, I want it to take these two nodes within this distance of each other. If you've ever seen the traveling salesman problem, and you want to find, the distance between two nodes. That is always helpful there. And it uses this arrow syntax, so that's 2 hyphens and a greater than sign. Or if you reverse it and it's going the opposite direction, it'll be a less than. Here's an example with the where clause. We can say match based on a pattern, and then just throw in a where clause to further filter it. And then we've got merge. Merge is great. It's the upsert of CYPHER. And I use that all the time when I'm loading data because I'm kind of lazy and I don't want to do the, okay, is it there or not? So here we have the set keyword and the merge keyword together. So we've got the hero hawk, description, always angry, sometimes green. All right, so I'm going to get into a demo here. And the demo is all about Black Friday, BONZAI bonus bacon bonanza. So think about Amazon.com. We've got buy one bacon, get a second bacon 50% off. Now that's a pretty popular deal. And this is kind of adapted from my previous client because they had a big Black Friday thing. And so the problem is that you can get too many people interested and then you got this huge back order problem. So we want to temporarily disable a product so we can do prevent back orders. And back orders kind of are no fun. So this is a query that's going to create our project. It's a project team. We've got match is the first one. And we've got our PMO. There's the group. And then all these merge statements that say, hey, if it's not out there with these properties, go ahead and create them. And then these last 3 say, hey, let's create relationships. Now notice again the directional syntax, and also that we have a label with that colon and the brackets in the middle. That says this is what kind of relationship it is, because you can filter on the type of relationship. And then I've given identifiers to each of these, okay? So that was a syntax error on my part. It's fixed in the query tool. Okay, so this is what that results in. And I will show you this live. It's just nicer when you see it after it's been arranged, and you'll know why in a second. So we've got a big push team, which is a team, a group, and then we have the project, which is the bonus bacon bonanza, and then we've got the group, which is the project management office. So all these relationships were created by that query. All right, so it's typical that with a big push, there's like 2 months, 3 months, and they say, hey, let's bring in 10 consultants, we'll fix every problem. So this is where we get into bulk data loads, right? Because we got so many consultants. And the great thing about Neo4j is it gives you some options in terms of how to get the data in. You don't always have to write all of these match and merge and create statements. You can actually just load in your data from a CSV. And I highly recommend a little tip here. Don't use the CSV convention. Use the tab. I don't know, I just like that. There's a couple keywords in there you'll want as that field delimiter. And then we basically give an identifier, CSV line, to every record in that CSV file. We also have the headers turned on. So what that allows us to do is say match groups based on the team, match groups based on CSV line.group, etc. So I'll go ahead and show you that. My screen's not duplicating, otherwise it would look there. Okay, so this is basically the format that we've got in there. This is an older version. But we've got just a list of consultants. We've got a developer named Hiram Gunn. and all those kind of things. Cindy heard, the project manager, because she herds the cats. So basically, what I want to do then is go to the query tool, and this is it, ta-da. Now, I'm going to do myself a favor. I'm going to start with a clean slate here. Okay? And I'm actually going to kill all the data in my database. Okay, so I had data as of an hour ago. I ran through this. But we're going to start clean here. And the first thing I'm going to do is create my node domains. Now remember I said web, process, human. That's what we're talking about. And this is a model. So I have a visualization. I ran a query. I created nodes. And here I have it represented. Okay, and then here's our node types. There's not a lot to see with that. We do have rows and graph that are just not there because I didn't return anything. We've got node types to node domains. Again, you'll have to take my word for it. And then we got node type relationships. Now, what you can see now is the testing domain. And that looks like this. It looks very much like the images I showed earlier. We're basically building a model that says we want to model everything in our process across systems, features, user stories, requirements, and have that traceability. Here's an example of the process domain. Now, something really cool here. Sorry about that, killing my neck. Okay, so I almost brought in a bunch of balloons because when you drag these around, it really feels like you're at a party. I mean, you could sit here for 5 minutes and then forget that you're at work, and then you remember, you say, okay. Now, once I position these, they are fixed. So I can create a nice little diagram, and I can drag this around still, but everything else is in place. This is nice because if you're too lazy to use Visio, this gives you a nice conceptual diagram. You can also, you can download this. Okay, so you got the ability to download this. If you look here, we've got export to SVG, scalable vector graphics. I've used that in the presentation that you saw. And it gives you a nice way to incorporate it into emails and the documents. We also have new with this version, we got PNG, JSON, and CSV. So if you would like to use a spreadsheet, you can always download the data and manipulate it later. Okay. All right, so we've seen some of the domains that we have available in our model. We're going to actually add some real sample data. And we'll add some real sample relationships. Okay, now, that project team that we talked about, this is it. Okay, so we have the big push team, the bonus bacon bonanza project, and all the consultants come from Zippity Inc. So we are dealing with just one vendor. All right, now we've got the new consultants. So I'm going to just load up that query here. You'll see it up at the top here. Everybody read that? Hopefully. And it's the same one that's in the slide deck. Hopefully I got the, yep, it's fixed. All right, so we're going to run that. Now, I just blew in a bunch of data. I've got teams, I've got roles, so this is a business analyst role, this is the big push team. That's kind of ugly, that's the Goldilocks problem, right? So we want to get something that's just right, so we're going to look at just the team. Notice we got 16 nodes here, just 16, but it's really crazy looking, so we're going to do just the team. All right, so this is a lot easier to read. We've got Verifier, she's a QA tester. And they're all associated, little hotshot, he's pretty good. They're all associated with the big push team. And so we've kind of got a pseudo-organizational chart already, just in our model. Have you ever been on a team where you go, I'm new here and I need to know about feature X, who's worked on that? Well, the problem is the guy that worked on it and knew all the stuff, he's on another team or he's at another company, and you're kind of screwed then. So if you want to look at the members of a team, we've got the member relationship. Sorry. And this is looking at a particular kind of relationship. We have member of, and it's matching anybody that is a member of something. Okay, so great stuff. If you ever want to see the whole view of the world and play with the balloons again. We've got, all these are developers. We've got the quality assurance team, and I believe we have a manager over here somewhere. So we're able to model the entire process of our development life cycle. All right, clean slate. Okay, so remember Kevin. Kevin has been given this problem he's got to solve. Would you rather look through the code, or would you rather run a query and navigate through this kind of data? So we've got the MVC views in the system. Basically, the project we had was a style sheet per view. You know, seems reasonable at first until you get 150 views. Okay. So right now in our model we have 2 domains, and we've got these kind of things. So we got MVC views right in the middle, and if you're going through the application, you're saying, all right, I've got the product view, I've got the JavaScript that goes with that, I've got the CSS, and all of a sudden you're able to just in a simple query expose that data to whoever needs it. Okay, this one is all the test cases that you would need to run for CSS changes. Now think about this. When you make CSS changes, it's like, well, who cares? It's not going to be a bug or anything. But you ever tried to look at a website in 10 different browsers, IE, whatever, and on our project we had to say, well, sorry, we only support IE 17 and it doesn't even exist yet. So you've got a whole set of test cases that your users need to run. And so what we have here, this is the actual sample data, it's no longer the model. Okay, so we've got a product list, that's an MVC view in the yellow. We've got test cases and CSS files. So I've built my query, and you see we're taking a test case node with any direct relationship to an MVC view that also in turn is related to a CSS file. So we're making these hops in the graph to get to where we want. Now in this case it's a very tight hop because I know which types I'm joining together. But I can actually say, I don't care what kind of relationship it is or how far it is, or I can constrain that to how many hops and see what's related. Okay, so we've got a product detail, MVC view, and then we've got our test cases. Now you can see at the bottom which one I've selected. Sorry. It's the shopping cart view cart test. Now if we change something, this flag that we're adding, we want to be able to temporarily disable a product so you can't buy too much bacon because we only have so much in stock. And it's not so much that we can't get more bacon, it's that we don't want to have 20,000 orders when we have 10,000 orders worth of supply. So we're going to go and have the testers run the view cart test, the change product quantity test, and so you can imagine all of these tests that they always run through, but we're not saying, hey, test the whole system again. We're saying targeted testing, so they can test just the parts that have been affected. And otherwise, you're saying, hey, just test the whole application. There we go. Okay, so next we have the data. Now, okay, so we've been looking at these diagrams over and over, and they're pretty. They'd be great for kids' parties, but what if we just want the data? Okay, so by changing the query to just pull out specific data elements, I can get the columns that are associated with the nodes. So all I'm taking now, I'm not getting a graph, I'm just getting the data, right? So this looks very much like a table, like you would get in a spreadsheet or in a relational database. And it's the same information, so I'm saying, I need to run test case view cart, change product quantity for this view, and that view. And you've done that just by modeling each component. Now this one looks at test cases that validate requirements, which doesn't work. Okay, let's go to this one. Here's MVC views that are missing test cases. Okay, so see these free-floating nodes? All right, I've got a query syntax here that allows me to optionally match nodes that don't have queries or CSS files. That's the wrong one. Let's try it again. Now see these views out here? They're just free-floating bubbles. They look all lonely. You can immediately visualize and you can see what's missing. You don't have to go, okay, left join, where x equals null and all that stuff. You can just run your query and look at what is not there, and then you immediately can target them. And then if you prefer to have the data, well, again, you can get just the data. So here is the names of the views that don't have test cases. And if you're into aggregate data functions, we have counts. So I can look at how many test cases I have per view. I know that the cart has 4, the product list and product detail have only 1, and then I've got all these other views that I haven't created that association yet. So I can start to look at my process and say, where should I focus my testing? Okay, this one is one of my favorites because this one involves deployment. Okay, have you ever wondered for what environment you've got what release and what defects are in that build? Okay, this says for this change set, I checked in this change set, and that was for defect 2819. Delilah Dev was the person that checked that one in. That's in release 1.3, which is in integration and dev right now. That's not production. So over here we have release 1.2, and that's currently in staging and UAT. And of course we've got other change sets and other defects. So what other way can you effectively portray all these things just with a simple query, right? So we've got a query that says, give me anything that's a defect, file, release, person, and in effect, we have this diagram and the data that goes with it. Jump ahead here. Okay, quick recap. What I'm telling you here right now is that you can use graph databases for systems that will help you in your dev process. Now, these systems are usable for production applications. You can do great things with them. Recommendation engines can use these. Oh, look, you bought socks. Well, you must want pants too. Okay, great. But what we really want is to introduce this concept. You're probably not ready to go change your SQL system into a graph database, and you probably shouldn't just do that. But the first strategy that I recommend is to model what you want to master. So those processes, those dev aspects, you know, you go to stand up, you the QA guy, the dev girl, she's like, you know, they're having these side conversations, but that information gets lost. And so putting it in a model is important. So what do you got to do? Well, you basically got to get your data from far and wide. Any kind of data that you can model that's useful, I would recommend to put it in a model like this. Your source control, your bug trackers, all these things can provide useful information. Now, don't just stop there. I mean, we've got things like user stories, backlogs, requirements documents. Now, I'm not saying that you document your requirements in Neo4j. Use your Word doc, that's fine, but put a placeholder in it that connects it to everything else. And then if you go even deeper, you've got things like SharePoint documents. I hate SharePoint, sorry. I did an open space at CodeMash called SharePoint where information goes to die. I've since revised that to call it Shareberia, where information goes to starve and then die. So, you know, if you're really into the knowledge management and you want to connect where information is, then I would say even include that. Your organization chart, I received a diagram at my last project that said, here's how all of our systems relate together. I'd never been given one of those. I was thrilled. But what it didn't have is the fact that Chris so-and-so worked on that system and had the knowledge, and then Terry so-and-so worked on this other piece. So I think you should connect the org chart and your system architecture. Now, go through your code base. I know regular expressions are painful. I don't recommend them for the faint of heart. But you know, you got all your JavaScript files. And think about Kevin. I mean, he's got style sheets to worry about, but what about the JavaScript that adds and removes classes? Let's think about that. Your views, your business objects. And then your tests. So you've got all of your automated tests, your integration tests, and then the features. I think you should enlist everybody. It's kind of like the stone soup metaphor. Have you heard that story where these soldiers come into town and they've come home from war and they're very hungry and there's a famine in the land, and they go around knocking on doors and they say, hey, can we have some food? And they're like, hey, I only got enough for me. We'll see you later. And then they get this idea. They put a big pot in the middle of the town square and they take a couple rocks and boil some water and put it in there, and people are starting going, what are they doing? We thought they didn't have any food. And so the townspeople come out and they say, well, hey, what you got going on there? And we're like, oh, we're making stone soup. All right, so then everybody's like, you know, they're like, oh, man, if we had some carrots, we could put some carrots in there. And somebody goes, well, I got a couple carrots I can spare. Here you go. And so it goes on down the line. We get potatoes and all the good stuff. And that's what this is. It's the DBAs. They're putting their metadata from the database. The QA folks are putting their test cases in. The business analysts are putting their requirements in. And not nobody's responsible for the whole thing, but when we all put it in, we get some nice soup. And if we throw in Neo4j, then that's the bacon. Okay, strategy number 2, connect what you want to control. So by connecting across these domains, the process, the human, the technical, you're basically giving yourself a big win, because the silo systems, if you have them at all, your ALM tools, your source control, they're not connected. And so you lose a lot of detail and things get lost. So if you really want to get control of your process, then building a model is a really good way to do that. So go get connecting things. Thank you. Do you have any questions? Any questions? Up front here.
What are the stories for inserting and retrieving data from code, not just from the tool?
Neo4j has a wide variety of libraries. You can use it from .NET, from Java. The J in Neo4j is Java, because that's where it came from. So it runs on Windows, it runs on Linux and Mac. So it's really flexible that way. You've also got some bulk data loading tools if you just want to go that way. And that's not just the load CSV command. That's things like bulk load tools, because it writes directly to disk. Any other questions? The question is there a visual way to enter data? There are some third-party applications. There's one based on Eclipse that can navigate and enter data. The browser query tool that I showed you doesn't do that. I've used Excel. I knock Excel, but one thing that it's great at is creating formulas to merge the nodes in. So that's one thing that you can do as well. Anybody else? Yes?
What's the equivalent for like an ORM for
There is a link style library available for C#. It's called the Neo4j client. That is a way that you can connect to it. Another thing it can do is return JSON to you. So if you've got an Angular application that just does data binding, it's got it baked in. So. Yes, the question is, will it take in JSON as well? Yes, it will. There's a post end of the API, just like there is a get. So when you post, you can post parameters that are JSON data objects. Any other questions? Yes?
What are the data types in a graph database? I noticed up there they're all just text.
Yeah, that's true. The question is, what are the data types that are supported? They're basic primitives. There's strings, numbers. I think it's integers and floats. And I don't know if there's actual date time support. I don't remember. But your lists of things are also supported. So, any other questions? If you're interested in learning more, there's a book, a free ebook about graph databases. And this one covers Neo4j in a large section of it. And the query language, CYPHER, is covered. It's from 2013, so you might see some things that differ from the current version, but it only gets better. And then Neo4j is where you can download it. There's a free community version, which is what I based all my stuff on. So, and if you have any questions, you can always feel free to contact me. Thank you. That's it.